Hello everyone, welcome again in Eng-Man YouTube channel. So we continue our learning on CMG CMOST, and in previous sections we have constructed the sensitivity analysis, and then we we check at the control center, and we see that the experiments were on progress, and then we stop the section. And as you can see, we have completed the experiments. And you check at this one, elapsed time, it takes 21 minutes, 40 seconds to complete all the experiments. And you see the engine events here, show all. You can check the note, job tight oil, number 79, and so on and so forth, complete launcher, and then start pre-simulation command, and so on and so forth. And you can also check the experiments table here, proxy role, training, you see, and we go to the right, at compressibility, this value, at that fracture permeability, fracture layer down, fracture layer up, the combination of all these parameters. So overall, we have how many? 93 or 92 experiments here. All of them are completed. Okay, result status. Some have the normal termination, but some abnormal termination. All right. And again, we do this sensitivity analysis. We do this experiment to know which parameter is really important for cumulative oil production, cumulative gas production, gas oil ratio, and which parameters that are not very important to influence that objective functions. Okay, the objective functions, the objective value that we want to know is, of course, the cumulative oil production, cumulative gas production, and gas oil ratio. All right, so we go back to the control center. Status complete, and this light green reused, we achieve 92% completed. And the result, 67 normal termination and 26 abnormal termination. You can check it also here, status summary and result summary. All right, so far so good. And then from control center, we can go to parameters. By the way, under the result and analysis, we have parameters, and then the time series, property versus distance, objective function. Okay, and we can expand the parameters. And yeah, you can see we have run progress, histograms, all experiments, histograms, filter experiments, and also the cross plot. We check the run progress, and we have all our parameters that we insert in our experiment. So let's check the first one, compressibility. So this is the, yeah, you can say the, yeah, the value of compressibility that we use. And you see we have random number, random selection of compressibility. Sometimes big, sometimes small, sometimes big, sometimes at the middle. Yeah, we pick the compressibility value that we put into our experiment. We take it randomly. All right. And also the fracture permeability. You can also check the value, by the way. The x-axis, the horizontal axis is the experiment ID, experiment number 1, experiment number 2, all the way to experiment number 92. And yeah, fracture permeability. This is the random selection, fracture layer down, fracture layer up, You see, we select discrete number, okay, for fracture layer up. So we don't have 1.5, 1.25, 1.3. We only have 1, 2, 3. We have integer for fracture layer up and fracture layer down, okay? Because in fracture layer up and fracture layer down, we are talking about how many layers that our fracture will extend to, okay? And we only have 1 layer, 2 layer, 3 layer, 4 layer, discrete, okay? Half length, okay? Relative permeability to oil. This is the curvature, horizontal permeability, vertical permeability, KVKH, porosity. All right, so these are, again, these are the values for each parameters that were selected to be used in our experiment. That's for the run progress. And we go to the next section. I will close this one and then let's open the histogram. Okay, the frequency now, compressibility, the horizontal axis, the for the each parameter, and the vertical axis, the frequency. For the compressibility, fracture permeability, layer down, layer up, half length, and so on and so forth. All right, maybe all of these visualizations, yeah, maybe it's not that we won't ultimately, but of course, because we are doing experiment, we want to know. We want to know the histogram, we want to know the run progress. But yeah, again, although this is not the final product that we want from our experiment, these are still important for us. The frequency, the histogram, right? Okay. So I will just go through and show the histogram for all of us. Okay, for the all experiments and also for the filter experiments. All right. Cross plot. Yeah, for we need to do the operation, but I will skip it for now. And another thing that's very important and interesting is time series, observer. Okay. Now, now this section is very, very important. The horizontal axis is the time, okay, the production time, and the vertical axis is the objective function that we want. And this one is the cumulative gas produced standard condition. And you see the legend. This one is the general solution. Okay, all the solutions that we generate from our experiment. And the black line is the base case. We have the base case from our builder, right? And this one, these blue dots are the field history. So by doing this, we are actually doing history matching at the same time, okay? But that's another story for another day. We will focus on history matching using CMOST. But right now, I just want to know what's the influence of each parameter, permeability, porosity, and so on and so forth, to my cumulative gas production, and what's the influence of the combination of these parameters to my production. And you see from here, okay, if I zoom in, a certain combination of my parameters produces a result a solution that is almost matched with my field history. Okay, so those combinations, those values of the parameters, maybe they are the correct solution that will mimic, that will match the field history. But again, that's another story for another day. So time series is very important. And now for the cumulative oil production, the first one is for the cumulative gas production. And yeah, the cumulative oil production. And now it's for the gas oil ratio. Interesting. Okay, and I will close the time series and parameters, property versus distance. Okay, let's keep it for now. And objective functions. Okay, let's expand this one. We also have run progress, histogram, crossplot, and proxy analysis. And proxy analysis is very important. Run progress, expand. NP is cumulative oil production. Okay, so this shows the cumulative oil production that we generate from each experiment, sometimes small, sometimes big, sometimes between big and small. So we can see the range that we have, that we get from the combination of our parameters. And again, and you remember that for each parameter, we have upper limit and lower limit, right? And for the GP, cumulative gas production, this is what we have. And for GOR, gas oil ratio, this is what we get. Still, under the objective functions, histogram. Okay, so yeah, this is getting more and more important. So now we have the frequency on the left vertical axis. On the horizontal axis, we have cumulative oil production. And on the right axis, right vertical axis, we have the cumulative probability. So now we can get estimation for P90, for P10, for P50 using this histogram objective functions, right? For gas, cumulative gas production, gas oil ratio, it's very, very important and interesting. Cross plot. Okay, now we have property versus distance, but we skip that. I want to focus on cross plot. We can click on this operation, select. Okay, and we can select each of these parameter to know the influence to our objective function. Okay, so for example, I want to know the influence of my horizontal permeability and the cumulative oil production as the objective function, the parameter from H. All right, beautiful. So now I know that if we increase the, no, if we have higher horizontal permeability, then generally we will have higher cumulative oil production. Okay. And this one, NP versus NP, it's not important. So how about this? This one, compressibility versus cumulative oil production, almost no influence. fracture permeability. Generally, as we increase the fracture permeability, we will get higher cumulative oil production. We can set the plotting here. I can have two plots horizontally and two plots vertically. So I will have 4 plots. Okay, and this is for the setting for the page. Okay, and I can switch to page 1 and page 2. Interesting. You can again click on this button and change whatever you like. So for example, let's focus on the half length against the cumulative oil production. Okay, because I just want to know one parameter, so vertically only one. I can say that, yeah, generally, if we increase the half length, we will get higher oil production. Okay, so yeah, by knowing this, you can design the fracturing design accordingly in such a way that you will get longer half length. Okay, you can design your fracturing job in such a way that you will get longer half length in your tight reservoir. Okay, and what else? Fracture permeability, of course. Yeah, I want to know KV/KH ratio on cumulative oil production. All right. So for this tight reservoir, if you increase your vertical permeability by increasing the KV/KH ratio, you will get higher cumulative oil production. But of course, KV/KH ratio is given. It's the property of your reservoir. You cannot increase the KV/KH ratio, right? I'm just saying that if the KV/KH ratio is higher or your vertical permeability is higher, for this model, for this reservoir, generally you will get more oil. Okay. All right. And then, yeah, you can also do cross plotting for GP and for GOR, of course, right? And what else? Proxy analysis. Now it's very important. NP. Okay, the first one, model QC. Wow. I think it's one of the most important for all this analysis, by the way, the proxy analysis. So you see the proxy predicted NP, cumulative oil production, on the horizontal axis, and the simulated NP on the vertical axis. You see this 45-degree line, the blue line, right? And the dash line, blue dash line, 55, 95 confidence curve. This trend, I mean this one, and that one. And training experiment, of course, by the CMOS is actually data analysis and sort of machine learning software. So we have training and we have verification. We have training experiment, we have verification experiment. And you see, we get relatively good result. So here, proxy model info, reduce simple quadratic, alpha 0.1, the R square for training 0.932, it's good, right? And the R square for verification 0.926, it's good. Okay, so you see, on one hand we have simulation, the result, the vertical axis, and on the other hand we have proxy model, which is sort of the machine learning version or regression version that is constructed from all of this experiment. So we have proxy model and we have simulation, and you see proxy model can sort of mimic the simulation result. So as a result, consequently, we can use the proxy model because proxy model will help us to predict in more quickly, right? Predict more quickly, so you can get the model, the equation from the proxy model to get the objective function to know to predict the cumulative oil production without doing the simulation. Because of course, doing the simulation takes time. Okay, it needs more concentration, more dedication. It is far more, far simpler if you use the proxy model. Okay, but of course you need to use the proxy equation in the limit that you use in the experiment. Okay, and we can also check in more detail the quality of the proxy model. Check it from the statistics, the R square, good, R square adjusted, R square prediction, good, mean of response, standard error, analysis of variance, okay, and then the effect screening using normalized parameters. And this one, the coefficient in terms of actual parameters. Okay, so yeah, this is quite funny. So this is maybe I can say one of the most important thing using CMOS is this equation. So instead of using the simulation, instead of running the simulation, I can use this equation to predict instantly the cumulative oil production using this equation and the data that I have. So if I know the fracture permeability, if I know the layer down, layer up, if I know the KVKH, if I know the half length, I can predict instantly the cumulative oil production without needing to running the simulation. It's great, right? It's great. And effect estimates. It's also another thing that's very important. We have the parameter, and I'm focusing on the NP. I can also do that for the GP, by the way, but let's focus on the NP. So NP. So as you can see, we have the maximum and we have minimum, but the most important thing is this one, the parameters. So as you can see, perm H indicates the longest bar horizontally. So it means the most important parameter that will govern my cumulative oil production is the horizontal permeability. And it influences the cumulative oil production positively. So if you have higher permeability, greater horizontal permeability, generally you will get more oil. KVKH also, but you see the pinch out, the relative permeability of oil at Conant water condition, and the NOG, generally they are not very important. Fracture permeability, of course, it's quite important. It gets the third rank, and then fourth rank, they pinch out multiplied by pinch out, but of course that's not, I don't know what pinch out multiplied by pinch out, by the way. KVKH ratio, and then half length, quite important, but not as important as the perm H. Yeah, you see, interesting, right? So I think this is another thing that you want to get ultimately from CMOS. So if you run CMOS, you actually want to get this equation, and you also want to get this visualization. And then Morris analysis. it's also, it shows us which parameter actually is the most important. So again, here, perm H. Again, the horizontal permeability is the greatest, give the greatest influence determining our NP. For GP, let's check the Morris analysis. Again, the perm H. And for GOR, Morris analysis, nothing very special influencing the GOR. But still, perm H, more important. Porosity gives negative effect on the GOR. So it means that if you have greater porosity, you will actually have less GOR. Okay, go back to NP, Sobol analysis. Wow, it's another thing that's very important, the parameter and the effect. Okay, the main effect, the green one, and this one for the interaction. You see, 58% influence actually comes from horizontal permeability, and the next one is fracture permeability, and then KV/KH ratio, and then half length, and so on and so forth. So although it's a tight reservoir, still, if you have greater permeability, generally you will get more oil. All right, and the proxy setting, the proxy model type, polynomial regression. You can also do neural network if you want, but I think it's a story for another day. Polynomial model type, find max R square adjusted. Yeah, that's what we want, because high R square, it means good correlation. Exclude statistically insignificant terms. Yes. Significance probability alpha 0.1. Yeah, generally we use that. And then let's go back to control center, proxy dashboard, proxy model generation. We can have polynomial regression, RBF, neural network, objective function proxy, and then let's expand this section. Okay, this one, the experiment, yeah, this is the experiment number 1 down to 92, the value, for the compressibility, for the fracture permeability, and so on and so forth. Proxy role as training or as verification, and generator, we use response surface methodology. And again, experiment ID, if we change it to experiment number 12, we have another combination. Okay. All right, so proxy model generation, polynomial regression, and then click on this button. The proxy model is ready for prediction. Okay. Build, and then RBF neural network. Press on that. The proxy model is ready for prediction. Okay. Beautiful. And then objective function proxy. Click on that. All right. So we perform polynomial regression, we perform neural network, and we also perform the objective function proxy. Let's check if we can. Yeah, the first one is the fundamental data series plot, and this one is the objective function data, the name, the objective function, cumulative oil, cumulative gas, GOR, QC simulation, QC polynomial, QC RBF, what if polynomial, sorry, and what if RBF, and go to fundamental data series plot. This one, open, click on select, and then for the SR3 time series, okay, for each the objective function, cumulative gas, cumulative oil, gas oil ratio. All right, click on OK. And yeah, you know, let's check the plot, the black line. Let's focus on that first. So this is the black line. This is the tight oil sensitivity analysis number 12. Okay. I can change to another ID. All right. Let's go to the first one. And then the polynomial regression for the ID1. This is the first method using the polynomial and using RBF neural network. It matches perfectly. All right. And polynomial regression, but using what if scenario, it matches the polynomial regression, and RBF neural network what if scenario, it matches the RBF neural network. But what about the field history? This one. So let's go to, yeah, you can change it manually like this. Okay. And plots on horizontal, we can get this one for the cumulative gas, cumulative oil, and cumulative, gas oil ratio. And yeah, you can also check it like this one, vertical 2. Okay. So you can, you can check one by one the your experiment. Now let's check the experiment. Yeah. So like this. All right. Yeah, you can do it. You can check one by one to know which parameter will give you the closest prediction to the field history. But actually that's a subject for history matching. But doing this CMOS analysis, it's not necessarily about history matching. Okay, it's actually about sensitive analysis. All right. Which parameter and which combination that will give you the highest cumulative oil production. And you can do that using polynomial regression. You can also do that using neural network, and then you compare the result from polynomial regression and the neural network. Also with this what if scenario, right? Okay. And by the way, for the what if scenario, you can adjust like this one to get, yeah, if you are doing the history matching, you can adjust this one in such a way that you can match the prediction with the history data. Okay. Porosity. Yeah, but basically you create another experiment, right? Like this. Okay. So, I think it's good. Yeah, it's good. So actually I almost match the experiment with the field history data. But again, let's focus on that on another video, another series. By the way, we have completed our sensitivity analysis using CMOS. So if you follow me from the beginning, you right now maybe already understand the powerfulness or the power of this software, right? It helps us to do sensitivity analysis. It helps us to do the data analysis and to compare it with the simulation. And again, what you actually want to get from this exercise is actually the proxy analysis, the result in terms of the equation and the visualization of how important is this parameter and how important is the combination of those parameters. All right, so I think we can call it a day. Thank you so much for watching. I hope you enjoyed the video. I hope this video is useful. Thank you so much for watching again and see you again in the next CMG or CMG CMOS videos. Thank you.